Join California Culinary Academy alumnus Greg Tompkins as he demonstrates the technique
to be a little more than 1 gallon per square foot per day.
Okay.
So for every gallon of water, we take about 1 1/10 square foot of wetlands to make this work.
But that varies depending on where you are.
The colder it gets, the bigger they have to be. Okay, in southern Florida, probably be half the size of this one.
I see.
All right, because it's warmer there. It doesn't get cold like here it does in Santa Fe, where it snows and gets below 0 degrees.
So the wetlands keep operating even when it's freezing.
Absolutely. And there's some really good reasons for that. One is that the water coming from the house is warm.
It's warm.
Sure, when you take a shower, that adds a lot of hot water, right? And the other one is that there's biological activity taking place. Okay, the organic material that's in the wastewater, and when you think about it, I mean, this is why it really does work, is we're just applying water and fertilizer to the plants,
To the
right?
plants, right.
All right.
So what are the plants that are growing here?
Okay, there's some wonderful species. The principal ones that we like to see are reeds, cattails, and bulrushes. And we don't have any reeds in this system, but we have a lot of bulrushes and cattails. This is one of the bulrushes, and it's a beautiful plant. As you can see, when these were put in, they were just a few short, tiny little plants like this, and they have over the course of a couple years grown into these big clusters of plant. And if you look inside, you can see that hollow structure.
Right.
And that's the
Absorbing lots of things.
Yeah, and also putting oxygen back down into the water. This is why they're so successful, is these plants have made this adaptation to living with wet feet. I like this dryland plant here. It has no mechanism for getting oxygen from this stem down into the water. These plants, bulrushes and the cattails, do that, and the oxygen contributes to the purification process.
I see.
All right?
But these plants don't live year-round, do they?
No, they don't. The tops will die off, but what happens is that this process, these tops dry out, but this structure inside remains. It doesn't disappear. And it's a mechanical process, actually. It's not a photosynthetic process. This is the amazing thing, is that every day when the sun comes up, or that warms up, the air in this expands, okay, and goes down into the root zone. And the roots themselves are probably only dormant for a very short period of time, maybe December to February, even in really cold climates. So there's still oxygen going down in there. Now, one of the things is that happens in the design, we have to make them a lot bigger in the wintertime because everything slows down. Plant transfer of oxygen, bacteria, you know, you slow down too in the wintertime, right? So
do you put different plants in the winter? Do you have things that come up in the early spring?
Once we plant, we don't worry about it. Now here at Soli Sombra, they've been interested in the landscape issues, so they put a lot of different species of plants in. They have daffodils blooming in the springtime here, for example. Cattails are one of the other important ones to us, and that's these plants here. And cattails have a similar kind of structure. As you can see, if you look in there, notice how that one is also made many different cells, like this one is here. If I break that open, so you can see that same kind of structure.
Mesh-like.
Yes. And it's incredibly effective for getting oxygen down there. And that's the adaptation. All we've learned to do as engineers is pay attention to what the wetlands biologists have told us about these plants.
I see.
These are superbly adapted to living in these kind of conditions.
I see.
And it takes the food, the nutrients, and cleans it up. A lot of these other plants Ben put in for landscape purposes, for the aesthetics of just having the color and the different vegetation for the, instead of having everything all the same height, they wanted to make it look like this beautiful garden.
I see.
Now these all contribute in their own way. Just think about what we're putting in here. We're putting in water with fertilizer, right?
Right. Is the water running in pipes underneath there?
No, it's not. This is the amazing thing. It's flowing under the gravel bed here. See, I can stand on it. And about 2 inches below me is the black water from the septic tank just walking underneath here.
I see.
Now, there's
and
no
it's gravity that's driving it throughout the...
Throughout the system, absolutely. Now, if you think about it, You know, if you've ever been around a big municipal wastewater treatment facility before, what's the first thing you want to do? You want to hold your nose, right?
Right. There's
Well,
no
look here,
smell here.
I'm standing right in the middle of one.
Yeah.
You smell the mint.
Wonderful.
Now we can make these big. We can make these up millions of gallons a day. It's been done.
Yeah.
Same idea, same principles involved right here.
They are adaptable to any size, from a private
Absolutely.
home to a whole community.
Absolutely.
How deep does the gravel go?
The gravel's 2 feet deep, and
All the way to the bottom?
all the way to the bottom. And it's important. The gravel needs to be clean. You can't just go dig up some sand and gravel from your backyard. It's sized. It's important to us to have it a uniform, more or less a uniform size. Most of the gravel is 1/2 inch to 1 inch. And then we put a little pea gravel on top, the smaller stuff you saw, just to make it easier to stick the plants in. You get little shoots from nurseries all over the country that grow these wetlands plants, and they're about this long. They have roots on them, and you dig a little hole in the gravel, dig down to the water. You start off with fresh water to begin with, and you stick that rooted cutting right into the water, gently cover it up, and away they go. Now, you got to plant during the growing season. It's like starting a garden. The best time to do it's in the spring.
If someone wanted an artificial wetland system in their home, what would they do?
Most states now have regulations about how to use these things. The EPA has published design manuals, and the TVA, the Tennessee Valley Authority, has a publication that's been real popular with people for backyard systems.
Well, it stands to reason that any plants are taking nutrients from the water.
Yes.
And that's bound to be helpful, right?
That's absolutely right. And there's some other things going on, too, is that in human waste, there's the potential for pathogens, some of them pretty deadly guys. So
Right.
what we also know happens in here in terms of the cleaning or purification process, and remember this happens in natural wetlands, too, is that there's some predators.
Predator microbes?
Predator microbes. They're basically amoeba types, or they can be protozoan community that basically are feeding on the pathogens as they flow through the water. They're like cottontails amongst the coyotes, in effect.
How do they get there? Do you put them there?
They're
do they
there.
appear naturally?
They're there. They're like that spaghetti sauce commercial. It's in there. They're there naturally. Remember, the whole basis for this, the wonder of the whole thing about natural systems is that this is the way Mother Nature has been doing it for probably 250 million years. All of the necessary organisms are in place to do the job that we want them to do.
If you give them time and space enough to do it.
That's correct. Absolutely right.
There's a lot of concern about coliforms in the water,
Yes.
in the food that we eat and the water that we drink. How does that apply to this system? Is there something that removes the E. coli bacteria?
Yes, there is. And it's actually a natural process. The E. coli bacteria are really adapted to your intestinal tract, okay? So when they get out of there, the conditions that you've seen through these wetlands are not the same. They're clearly different. That weakens them and makes them subject to predation. That's principally what happens to them. What we see by the time, in the millions of them, per 100 milliliter sample, millions of colonies of fecal coliforms get reduced down to a standard that meets the recreational standards for swimming. Okay, that's lake swimming.
Yeah.
Definitely that kind of thing. So it's a natural disinfection taking place. We believe it takes place for other things too, like cholera, and for other more serious illnesses than those associated with ingestion of fecal coliform. Essentially, as part of this area, water clearly is starting up behind me and flowing sequentially through each of these beds. It takes time to go from here to the end of the system. And it takes, in this case, if the place was filled up with all those people, it takes about 7 days. Okay?
From the house to the end of the system.
Yes. Okay.
That seems pretty fast.
You know, I never thought about it that way, but I thought it was a long time.
Well, it seems like from black water to clean water, 7
worth it.
days is pretty fast.
Yeah, and I think it's worth it.
This is built on a slope. Does it have to be on a slope?
No, it doesn't actually, Judy. You can build them on flat ground. In fact, it's actually easier as far as the construction process if they are built on flat ground. This is purely an adaptation to this site.
And as are the 4 beds.
As are the 4 beds.
You could have 2, 16,
sure.
1.
Anything you want.
Whatever fits your slope.
Yes.
If it's not on a slope, how do you get the water to move?
And that sometimes requires the use of pumps.
Pumps.
And we like to avoid that because pumps take electricity and somebody's got to maintain them. So if we can let gravity do it and Mother Nature do it and nobody needs to get involved, that's the best way, clearly. Let me just point out one other interesting idea here that Ben Haggard did when he planted this. You can see those grasses back there, those ornamental grasses.
Yeah.
They probably are very good for water treatment. There's been some research been done on them, but they're also very valuable as landscape plants. I think the buckets, the 1-gallon buckets, probably sell for about $5.95 at the nursery, right? So if he were harvesting them on a little nursery operation, you could put this thing to work and generate a little...
Creating income as well as clean water.
Well, you've got it.
We think about plumbing systems and wastewater treatment and all of that as very technical, something that only engineers know about. But in fact, this is a really simple system, isn't it?
It is. You know, one of the things we like about it as engineers is that ultimately it is simple. I mean, when you think about it, we're just growing plants.
There's no machinery involved, nothing that needs constant maintenance and repair.
That's one of the beauties of it. These things are self-maintaining, self-regulating. There's nothing to break. There's no pumps, there's no aeration equipment. Nobody has to come along and
don't have to come pour chemicals on it.
No chemicals required. Everything's there to do the job that we need without any intervention by humans. No maintenance requirements, no electrical requirements. It's marvelous from that respect. Machines break and need to be repaired. Ultimately, if we can get rid of them for our wastewater treatment system, we'll not only save money, but we'll eliminate the likelihood of pollution due to the failure of equipment, which happens all the time now.
Is that possible in this system? Is it possible that something can fail and wash a bunch of black water into the vegetable garden?
It's a good question. Yes, there is. One of the things that can happen is that these systems can be upset by toxic chemicals. Let's say they dumped a bunch of weed killer down the drains. All right? That would kill the plants. So it would take a while before the system came back. If they put lots of bactericides into the system, that would kill the septic tank and then would kill the bacteria that was in here as well. So those, although highly unlikely, in fact, I would say not likely at all in this case, in certain circumstances that is a concern, and we do pay attention to that possibility because that will affect the treatment system. They spring back ultimately. Nature will recover, but you'll be in trouble for a couple weeks at least.
Yeah. What happens if the millers go away and nobody's here for a couple of weeks? There's no water running through. Do the plants die?
The remarkable thing is that the plants just go dormant. They'll just sit around and wait for that water to come back. The reed seed, for example, has an ability to survive for 10 years in the absence of water. So it can go that many years before it has to grow again. And when the water comes back, it starts to grow. In this short-term circumstances, remember that there's a lot of water sitting in each one of those wetlands. Those gravel beds are 2 feet deep. So they could go away quite a while before all the water was used up. And it does rain.
Moves more slowly.
Moves more slowly or stops altogether. Yeah. And there is a little bit of rain, even in New Mexico. And if we need to, like for school systems, where everybody's gone in the summer here, what we do is just hook up the roof drains because the rains come in the summertime in New Mexico, so we let the water from the roof water the plants.
I see.
Intelligent design now. This is the final sump, and we're going to look from where it flows from here. This plant is called the water hyacinth. They have a beautiful little purple flower on them, and you can see the fine root structures down here on the bottom, and this is where the bacteria grow that help with the final treatment.
So these plants are continuing to clean the water after it comes out of the beds.
They're continuing the process, right. Now the water here, we've tested it for bacteria, so I'm not worried about it. This is as good as the Lake Elephant Butte. It meets the recreational standards for bacteria, so I could take a swim in here at this point. And just to give you an idea, one of the things we look for when we do the water, remember, it's black when we start off with, but you can also see there's some little tiny swimmers in here that are associated with clean water. All right, they're the final, they're called copepods, and they're indicators of clean water, and it's a way that we can, just by looking at, to see who's home here, you know whether in fact we've got clean water. In other words, we don't need to make it drinking water, because of the end result is to use it on the garden for irrigation, okay? So we're cleaning it to a particular level. In fact, we are reusing it in buildings, and you can take it to the next step, which is to add an additional filter and disinfection step if you wanted to make it drinkable. But nobody's going to drink it because of psychological reasons. I don't believe anybody will, at least not for next 100 years or so. This thing has been extensively tested, and it meets the standards that the state of New Mexico has for the discharge of wastewater back into the ground. One of the extraordinary things about it is there's essentially no nitrates in the water. The federal guidelines and standards are 10 parts per million of nitrates. There's essentially less than 1 always in this system. So it meets the nitrate standard consistently, winter and summer.
When you have these torrential downpours, does that throw the system into some kind of a problem?
Actually, it doesn't. It really helps. I mean, if you think about it, rainwater is clean.
Yeah.
So.
But doesn't it rush everything through faster?
Well, but at the same time, it's diluting everything too. So it does go through faster, but it has the effect of diluting at the same time. Okay, let's take a look at the final place for the water, because we're seeing a lot of this. In fact, this is kind of a small version of some of the big municipal systems here. What do we do with the water when we're done? Well, we can create habitat with it, reuse it, and you can see here they've done an extraordinary job making this very nice landscape pond. And look, there's tadpoles.
Yeah, I see lots of tadpoles.
See the goldfish growing in there?
Uh-huh.
These are water lilies, which will have beautiful flowers in the middle of the summer. There's all kinds of critters that live in this water as well. And you can see, you can see the bottom of this pond. There's a little stuff floating on this water, which is blown pollen and dust. But again, the water quality is real important. And you can see that. And you can see the tadpoles growing in here. So we know we have clean water. We also test it for those kinds of water parameters that the state requires, the water chemistry. But ultimately, it's going to be the biology. You know, what's growing in here in terms of things like tadpoles and the fish. Are they surviving? How well are they doing? That really tells us whether we have healthy water or not. This water then flows into the garden to irrigate with. Before, just to give you some relative numbers, we have a number called biological oxygen demand. It's a water quality number. That's 140 parts per million coming out of the septic tank. It's down to 5 here. So that's a level and pollution, a reduction in the level of pollution that we've made to the groundwater by just adding that additional treatment step. Now remember, there's still a final treatment step, which is real important to understand, is that once the water's been cleaned up to this level, and we know life can live in it, by running it through the soil, we get an additional treatment as well. By irrigating, the final last drop of nitrogen is gone. Any remaining bacteria are filtered out by the soil. Any phosphorus, which is one of the principal nutrients that very difficult to get out of wastewater treatment facilities, is taken up by the plants and by the soil.
So the water goes through here to water the ornamentals over there,
yes.
And that's where it goes back to the water table.
Exactly. Now cleaned and purified. So there are 2 functions, right? One is to provide a little reuse, but the principal one is really to protect the underlying aquifer by this additional treatment process. Essential. Essential. In New Mexico, in fact, many states have over 50% of their population on septic tanks and plain old leach fields, and literally we're flushing our toilets into our drinking water out west. You think about that around where you live in Austin, the aquifer, the Edwards Aquifer there is...
That's right.
It's what you're doing.
And the rivers and streams.
And the rivers and streams, right.
Yeah.
So this helps, and as you can see, it provides an option for landscape, and it also provides habitat. One of the things, of course, we didn't see is all the birds that come to visit.
Right. Birds and rabbits. And I have a whole different perspective on wetlands now. I never realized how essential they are to keeping our planet clean, keeping the water available. Thanks for sharing the information with us.
It's been a pleasure, Judy. I've enjoyed it very much.
We found out today that there are ways that are simple, effective, and inexpensive to clean water and to conserve water. I hope this applies to our homes and our communities all over the country. I'm Judy Barrett for The New Garden. Join us again next week.
The New Garden has more than 50 programs available on this and many other thought-provoking gardening subjects. To order your own videocassette copy of any program in the New Garden Natural Gardening series, write us or call 1-800-238-6666. Each videocassette is $24.95, including postage and handling. All credit cards are accepted. You can also discover sources for plant material that you've seen on this program by subscribing to the New Garden Journal. The journal is designed to help you apply knowledge, not chemicals, to your garden. Enjoy your garden more using the valuable tips from the New Garden experts contained in the New